Welcome to the deep dive. Today we're looking at something pretty fundamental, the evolution of projectile weapons way back in the Paleolithic. It's an amazing story, really, stretching over millions of years, from basically a pointy stick to, well, applied physics.
It really is. And for you listening, we want to frame this around three core ideas. First, what actually changed technically with these weapons? Second, what problems, what survival challenges did these changes solve? And third, how did all this technology end up reshaping, human society and even how we think?
Okay, let's dive in. Phase one, the simple wooden long spear. We're talking really old here. The shooting spears from Germany, about 300, maybe 340,000 years old.
Yeah, Neanderthals or maybe even Homo heidelbergensis. And what's amazing, like you said, isn't just that they used wood, but how they worked it.
They weren't crude at all, were they?
Not at all. These things were engineered. They used stone tools, carved the tips very carefully. They even made sure the weak inner part of the wood, the pith, wasn't right at the very tip.
Maximizing durability. Smart.
Very. Keeps the point strong. But, there were still big limitations.
Right. The main one being, well, us. Human strength. How far can you realistically throw a heavy wooden spear effectively? Maybe, 15, 20 meters?
Exactly. And if you're facing down a large, dangerous animal being that close, that's a huge risk. Plus, just wood doesn't penetrate that well sometimes.
So that immediate danger, that need for better penetration and maybe more distance, that pushed innovation.
It had to. Which brings us neatly to phase two, the stone-tipped spear. This is a huge leap. Conceptually, the composite tool. We see evidence around 500,000 years ago. Kathupan in South Africa is a key site.
And adding that stone tip solved the penetration issue.
Big time. It wasn't just sharper. Experiments show stone tips transfer kinetic energy much better. They create something like a 24.8% larger wound cavity inside the animal.
Wow, nearly 25% larger. That's a significant improvement in effectiveness.
Absolutely. Suddenly, taking down larger, tougher prey becomes much more feasible. And the stone tips themselves weren't simple flakes. Often they used really sophisticated techniques, like the vol.008 method. That's where you pre-shape the core stone carefully to get predictable, efficient flakes. That takes serious planning, abstract thinking.
Okay, so you have the shaped stone tip, but then you need to attach it securely to the wooden shaft. That's the composite part. How did they manage that?
Adhesion, glue. And this is another amazing bit of ingenuity. Neanderthals, for instance, figured out how to make birch pitch.
Birch pitch? Like a tar?
Sort of, yeah. It's a strong adhesive, but making it requires heating birch bark in an oxygen-limited environment to very specific temperatures. We're talking 300 to 400 degrees Celsius.
That's incredibly precise temperature control, basically early chemistry, right?
Yeah.
Just to make glue.
Exactly. It shows complex planning, fire control, understanding materials. It's not trivial.
Okay, so stone tips make spears deadlier, more reliable, but you're still limited by throwing distance, by human muscle power.
Right. Which leads us to phase three, the atlatl, or the spear thrower. This is where applied physics really comes in. The earliest solid evidence in Europe is around 17,500 years ago.
The atlatl. It's essentially a lever, isn't it? It extends your arm.
Precisely. It acts as a lever, lengthening the force arm, which drastically increases the dart's velocity. Plus, the dart itself is often flexible, storing and releasing elastic energy like a spring.
So it's a force multiplier. You're breaking the biological limit of the arm.
Totally. The results were dramatic. Range jumps from that risky 15, 20 meters to maybe 70, even 100 meters, and speed up to 150 kilometers per hour.
That changes everything for hunting dangerous Ice Age megafauna like mammoths. You can hunt much more safely.
It was a genuine super weapon for its time. It likely reduced hunter injuries and deaths significantly, making hunting large game far more sustainable.
So let's connect the dots. We've gone from shaped wood to complex composite tools needing controlled fire to applied mechanics with the atlatl. What did building and using these increasingly complex tools do to human brains and societies?
Well, the cognitive demands are obvious. Making a level up point or figuring out atlatl mechanics requires planning, spatial reasoning, problem solving, and probably complex social learning to pass the skills on.
You need to teach someone how to do this. It's not intuitive.
Not at all. And it's fascinating that this technological ramp-up happened alongside that huge threefold increase in human brain size during the Paleolithic. There seems to be a feedback loop. Complex tools demand smarter brains invent better tools.
Some research even suggests tool making activates brain regions related to language processing.
That's right. The planning and sequencing involved might share neural pathways. And think about the social impact. Better hunting means more reliable, high-quality food.
Which allows groups to grow larger, become more stable.
Exactly. And perhaps allows for more specialization. You might have expert toolmakers, expert hunters. This requires social structures, ways to transmit knowledge effectively across generations. Culture, really.
So this whole journey through Paleolithic weapon tech isn't just about hunting. It's deeply tied to our cognitive and social evolution.
Absolutely. That atlatl, it's really humanity's first clear success at using an external tool and a grasp of physics to overcome our own biological limits.
Extending our reach, our power through understanding mechanics.
Precisely. And that fundamental idea, leveraging principles beyond our biology, you can draw a straight line from the atlatl to, well, almost all complex technology that followed. Levers, pulleys, engines, even rocketry. It starts there, which it maybe leaves you with a thought. What biological limit, physical, or maybe even cognitive, are we trying to transcend with technology right now?